Okay, so you're going to get some assignments coming up in this unit where you have to look at the addition of vectors, and sometimes we have two different ways of having it happen. So in one case, what we can have is where we have objects that are, I'm going to call it moving together. And that doesn't mean things coming at each other. What that means is that the motion of one object affects the other object, then I'm going to add the vectors. For instance, let's take the example of maybe there's a river, and this river is moving to the left at 3 meters per second. And we have a person on a boat, and the boat is moving this way at 5 meters per second. So in this case, what I need to do is say, alright, the objects, let me just draw a little bit more river. The motion of the river does have an influence on the motion of the boat. So in that sense, we're going to say, oh, they're moving together. So in other words, the river carries the boat this way. So in that case, I'm going to add the vectors. And an easy way to think of that is what if the river went this way? If they're moving in the same direction, clearly that would make this go faster, so I'd be adding 3 to 5. But remember, because they're going in opposite directions, and we're talking about vectors, vectors have a directional component which we can indicate with a positive or negative sign. So really you can think of it is let's make this the positive direction. By convention we use the direction to the right is positive and the direction to the left is negative. So I'm going to put a little negative sign in front of this. That's really the key to solving this. So watch, I want to see what is the net velocity. So in this case my net velocity is going to be whatever I get. I'll just finish writing velocity. Alright, it's what I'm going to get when I add these two vectors. So I'm going to say net velocity equals 5 meters per second. Now watch this, careful, careful, plus negative 3. So you've got to remember that for this to work. Plus negative 3 meters per second. And what that's going to give me is 2 meters per second in a positive direction. Now had that been a negative value, if this had been the negative and this had been the positive, I would have ended up with a negative one. That would mean it was moving this way. But since I got a positive one, it means it's moving in the positive direction. Okay, let's try another one. Now in this case what we have, we're going to try another moving together one. So remember, that doesn't mean two things moving together. It means one thing, say a person on an escalator, a person on a river. How about this? Let's do a bird. We have a bird that's flying this way at 16 meters per second. Now I'm going to use the convention that this direction here constitutes the negative direction, so therefore I'm going to go ahead and make this negative 16. Now the wind is blowing, you know what, let's have the wind blowing in the same direction. The wind is blowing this way, pushing the bird in the same direction as trying to fly. Now in this case, the wind is blowing at 20 meters per second. But since it's also in the negative direction, I'm going to make it negative 20. So, well, what's the velocity? Well, in this case, the net velocity is going to equal, remember, when they're moving together, when one thing is moving under the influence of another object, we're going to add the vectors. And since this one is going to help this one move, we're just going to add them, and what we're going to get is negative 16 meters per second plus negative 20 meters per second means that that bird is flying at negative 36 meters per second. And then I can use this value here to solve for distance, or I can use it to solve for time in the equation velocity equals change in position, otherwise known as displacement, divided by time. So what I could do then is I could take this value right here and put it in here. Let's try another one. Okay, this time let's look at things that are separate objects. So this is like cars coming towards each other or moving away from each other. So let's try this. We have a it's dodgeball. So what I've got is this. I have a person who is running to the right at 7 meters per second. And a dodgeball has been thrown at that person and that dodgeball is traveling towards that person at let's make it 21 meters per second. Now what I want to find is what is the net velocity. Now in this case, it turns out the motion of this ball in no way affects the motion of this person. Unlike in the river or the air where it moves the other object, in that sense they're separate objects. And so separate, subtract, it alliterates. Get it? So what we're going to say is this then. We're going to say, well, in this case, whoops, the net velocity is going to be found by subtracting. So I'm going to say 21 meters per second minus 7 meters per second. And that's going to give me, I don't know why I switched colors on you, I'm sorry, a net velocity of 14 meters per second. Now, what if this person over here got really, really scared and really poured it on, or went Lance Armstrong and took some steroids, and this person really ran fast? This person set a world record. This person ran 21 meters per second. Well, this happens to you all the time on the highway if you think about it. This ball is going 21 and this person is running away at 21. Clearly, that ball is not getting any closer to the person. Just like if you're driving down the highway at 40 miles an hour and I'm in front of you driving 40, my bumper doesn't get any closer or farther to you. It's almost as though I'm going 0. We would say I have a relative velocity of 0. Well, in this case, that's how I remember it. 21 minus 21 equals 0. So that's how I remember that if the objects are separate, I subtract the vectors. Let's try one more and call it good. Alright, how about this? We have, and I'm not very good at horses, but here we go. I have a knight on a horse who is jousting. That's a terrible knight on a horse. And this jouster is going towards the right at, let's make it 8 meters per second. And I have another jouster over here, and this jouster is moving in the opposite direction. Let me try drawing a horse. Oh gosh, I'm terrible at horses. Looks like an iguana. Okay. And this it's really bad. Okay. And that jouster, oh my gosh, is going in the opposite direction at, let's make it, okay, how about 10 meters per second. Now you got to be careful here because clearly they're going to collide faster than if one of them wasn't moving. So what I have to remember here, what's really tricky is, remember that this is the negative direction, so this has to be a negative vector. Make it negative 10. So now I'm going to do, since they're separate objects, the motion of this one does not affect the motion of this one, I'm going to subtract the vectors. So here you go, I'm going to say 8 meters per second minus negative 10 meters per second. And when I do that, what it's going to give me is a collisional velocity of 18 meters per second. So that's the trick, kids. All you got to do is you got to say if the motion of one causes the other one to move with it, then they're moving together. We're talking about like birds in the wind, or airplanes in the air, or swimmers in the water, or a person on an escalator, something like that, moving sidewalks. You add the vectors because one influences the other. If I have two objects that are on a collision course or moving away from each other, then I have separate objects that are not influencing each other. I'm going to subtract. Separate, subtract. There you go. Well, I hope this helps. I don't know if it does. Let me know one way or the other so I know whether to invest my time this way in the future. Signing off. Bye.